So what I'm reporting on today is a cyber infrastructure project that's enhancing collaborations between the National Center for Atmospheric Research and the National Ecological Observatory Network. And these are both major NSF facilities in Boulder, Colorado. And I want to acknowledge a larger team of collaborators at NCAR-NEON. This is a much bigger project than me. And this is also work that's in partnership with the CI Compass team and is supported across the SciS, Bio, and Geo directorates at NSF. And so yesterday we heard from NSF about democratizing access to science. And that's exactly our aim with this project. It's to bring new voices to climate science and bring new collaborations and new teams to climate research at NCAR. In this case, there are many overlaps between NCAR and NEON in terms of the models and observations of the land and its terrestrial ecosystems. We at NCAR model the land surface and its interactions with the atmosphere as part of our community Earth system model. NEON observes the land surface and collects measurements on the land surface. And both organizations provide data to the research community. And a recent National Academy report on Earth system science at NSF highlighted this work as an example of synergies among NSF facilities. And so what we're doing with this project is we're developing new tools to integrate NCAR models with NEON observations. What we're looking for is a supported portable computing environment to enable scientific discovery and innovation by university researchers with diverse backgrounds, primarily people without access to high performance supercomputing and people who traditionally don't work with climate or Earth system models. We want to further develop and improve our models at NCAR. And then we also want to enhance NEON measurements and data distribution. And again, as I said, this is a pilot project that was funded by the SciS, Bio, and Geo directorates. Our cyber infrastructure needs are actually fairly, are basic, I think, but there are three things. We're looking for a portable computing environment from laptops to high performance supercomputers. Most of the work we do at NCAR is actually on our supercomputer. This is the Cheyenne supercomputer that we use, but we're trying to create access to this from a variety of different platforms and people without access to high performance supercomputing. Then there's the real-time, we're looking for near real-time data exchanges between NCAR and NEON, the NEON data to run our models and test our models and compare back with observations and the model output that we're providing. Can we do that in near real time? And then we're looking for interactive data visualization and exploration. We want to make the accessibility of the model output and the project available to people who don't necessarily want to run the model, but actually want to see model output. So how can we make that easier for them? And so the portability across platforms is achieved using a containerized environment for our community Earth system model. Yesterday, Brian Dobbins presented on work he was doing on cloud computing for the CESM. He also leads the development of our containerized CESM. It runs on Mac, Windows, Linux systems from laptops to servers. It's fully pre-configured, there's no installation or porting required. And this container allows us to help students and researchers get up and running on CESM in minutes versus the days, weeks, or months it normally takes to get the people to port the model and get it up and running. Additionally, we can distribute training materials with the container. And so the containerized environment is pre-configured with the model itself, but also Jupyter Lab and what we're calling a CESM lab. It's portable and ready to run. And container is the key technology here. It lets us package a whole environment for an application like CESM and provide it in a simple portable form. This isn't just the model source code, it's also the libraries, compilers, tools, and more that have to go into creating a usable environment for modeling. In our case, this really includes, a key thing is the inclusion of Python packages, which are needed for visualization and analysis and for interactive tutorials as part of the containerized environment. So what we've been doing for this project is to add on to the CESM lab. What we're looking to do is have regular testing, evaluation, improvement of the land component of our community Earth system model. And we have new software tools in the container that access surface characteristics and meteorological data from NEON. These are the data that are needed to run the model. And then we have the observations of fluxes and other ecosystem and hydrologic state variables that we use to test the model, again, from NEON. And then what we're doing is we're sending model output back to NEON for hosting and visualization as one of their data products. And in this way, we're broadening the usership of NCAR models and the NEON data. The modeling system utilizes measurements and observations at numerous sites throughout the US. There are about 47 different sites at various locations, various ecoregions of the US where NEON collects its measurements. And what we're doing is we're providing hindcasts over the period in which observations are available. And then we're updating the simulations as new observations come online. There's been a lot of talk about what we now call Earth system prediction, which is expanding beyond just sort of simple climate forecasts and climate predictions. And we see Earth system prediction as including forecasts of ecological and hydrologic fluxes in states. And the NEON project provides a tool to do that and actually then compare to observations to see how well our predictions are doing. And so this allows near real-time predictions about phenology, water, energy, carbon fluxes at these locations. And what we're seeing here is an example of a collaboration we have with Northern Arizona University, where for these two particular sites, we're actually modeling the productivity of the vegetation shown in blue, and the Northern Arizona colleagues are measuring the greenness of the vegetation shown in black. And so we see this as an opportunity for a really increasing collaborations with universities on model improvements, initialized predictions, and things like machine learning and data assimilation and other opportunities. The key innovation here is to simplify the modeling process and increase accessibility of the models. The process for running the model at these individual tower sites is cumbersome and very error prone. It involves formatting and pointing to the meteorological data we need to run the model. It involves changing surface data sets to configure the model to look like the vegetation the site we're trying to represent, and other configuration variables. And what we've done is we've streamlined this now all into a simple single line of code and included that in the container system. Also included in the CS lab environment are instructions for downloading and launching Docker, running the CLM simulations at the NEON sites, and visualizing and evaluating the data. So the container contains everything one needs to actually run these sites and get the model up and running and do the simulations and science in a very easy and configurable way. A key part of this, another part of this is actually the visualization of the data. We've included tutorials on visualization in the CESM lab. This is just an example using a bouquet. We're looking for web-based data exploration of simulated and observed data so that people can look at the output without running any simulations at all on their browser. In this way, they can look at used for classrooms, for teaching, and to engage students. What we're seeing here is results for one particular site. There's a drop-down menu that allows you to choose between various different sites that we're simulating, and you can look at different variables of interest from the drop-down menu, and also at different time scales from hourly to daily to monthly. So the visualization is included as part of the CESM lab environment for researchers to use in their own science, but it's also web-based on the NEON data portal as the model data gets back to them and they can visualize it that way. And use it without actually having to run the model themselves. So again, yeah, the goal of this project has been to promote community engagement, expand access, and broaden participation in climate science and in particularly modeling. And we think this offers a low-cost, high-impact science tool that opens opportunities for communities that traditionally have not been involved with climate modeling because they don't have access to advanced computer resources or they have little modeling experience. And you can see in these two quotes we put up here, there's a need for this in that people are, particularly from the ecological community, want to get involved with modeling. They actually may not have the skills and the resources to do that, but they would like to do that. And as you can see from one of our colleagues at Auburn University, yeah, this tool creates a new frontier in data modeling and understanding our changing environment. So thank you. And thank you to all the team at NCAR-NEON and CI Compass who's made this possible.
Thank you, Gordon.